So hey guys, how you are doing? Hope you are doing extremely well. Welcome back to the GFG POTD series. Okay, so it's our day 10th of solving the GFG POTDs. Let's look at the problem of today. So it says determinant of a matrix. Given a square matrix of size n star n, the task is to find the determinant of the matrix. The constraints of n are given to be up till 10. So how can we solve it? Okay. For the audience who doesn't know what is the meaning of determinant, let me explain. So, determinant, I'm not going into the depth of what how determinant began and how it all went. I'm just explaining how to calculate determinant. Suppose for n equals to 1, the matrix would look like A00, right? The determinant would be A00 in this case, okay? For n equals to 2, the matrix would look like A00, A01, A10, A11, correct? So in this case, my determinant would look like multiple of this minus multiple of this. That is A00, A11 minus A01, A10. Okay. For n equals to 3, how can we calculate? The matrix would look like A00, A01, A02, A10, A11, A12, A20, A21, A22. Okay. So how will we calculate? The method to this is select this element, okay, add it with plus sign, then go alternately. This with minus, this with plus. I'm not going into the code, I'm saying how we calculate in humanly method, okay. Plus minus plus. Mark it as plus minus plus. Then for this one, this element, what you have to do, hide its row and column, and for the rest of the matrix calculate a determinant. Suppose this determinant is d1, okay. So your answer would be plus of a00 multiplied by d1. Now for this element with minus, hide its row and column. Now for these elements which I'm circling, 1, 2, 3, 4, the elements which are there after covering the row and subsequent column, let's say that their determinant is d2, so it would be minus of 0 1 multiplied by d2. Then for the third one, hide its row and its column. Now it would be plus a02 star. Suppose this matrix will give us d3, so it would be a02 star d3. Okay, this will be our determinant. This topic is generally taught in LA, linear algebra, during college times, or during the school times. While I was preparing for JEE, it was also taught to us. Not a difficult topic. Scoring marks in determinants was pretty easy that time. Now coming to the size of 4. Okay, how would we calculate that? For n equals to 4, you will have to calculate like, suppose a00, a01, A02, A03, then comes A10, A11, A12, A13, A20, A21, A22, A23, then A30, A31, A32, A33. How would we calculate for this? Same step, plus, minus, plus, minus. Now for the this one, hide its row and column, matrix of determinant of this, so it would be a00 d1 minus a01 d2 plus a02 d3 minus a03 d4. This is the determinant for n equals to 4. So can you observe a pattern? Like for every time, like in the third case, what we were doing, we were covering the element and making a problem statement smaller. Like it was going from n equals to 3 to n equals to 2 case. Now for n equals to 4 case, it is going from 4 to 3, then it will go to 2, then return back. So how can we do it? I say suppose we have been given the, let's see the problem state example only. 102 minus 1 3005, that is 102 minus 1 3005 3005 214 minus 3 214 minus 3 1050 1050. This is our input matrix. Okay, I say the code should go like this. If n equals to 1, if the size of the matrix is 1 star 1, just return that element. Alright. Else if n equals to 2, that was also pretty straightforward. What was the case in that? That was a00 minus a01. So it would become like here, yeah. It would become like return mat 0 0 star mat 1 1 minus mat 0 1 star mat 1 0. Okay, this would be for else if n greater than equals to 3. Now we are handling the case of n greater than equals to 3. So how do we handle them? I say suppose int element equals to mat uh, sorry, what I am saying is keep a sign, like we were doing alternate sign, like this plus this minus this plus this minus. So keep a sign, as sign is positive in the first, I'm keeping positive as 1 and negative is minus 1. Okay, so sign is plus 1 at right now, answer is 0, answer contains a final value. Then what I say, now for int column equals to 0, column will go up till n minus 1, column plus plus. What do we have to do? Now if you see, I am taking the column because we are traversing the row now. So this will be 0 star j 0 j. The entries in this column can be represented as 0j because the row is fixed and the column is varying. So this will give rise to all the columns. So what I am doing is element equals to sign star mat of 0 column. Okay, then sign becomes minus sign for the next traversal. Then what do? We construct a smaller matrix. How? In the following way. What do? For int I, now to construct a smaller matrix, we have to consider only this values. Okay, for this one, this values, for this one leaving this row, for this one leaving this column, for this one leaving this column. So you can observe in all the cases the row is starting from 1 only. Row is not starting from 0 because 0 is always a case of hidden row. So we have to start our row from int I equals to 1, I goes up till n, I plus plus, and column will start from 0 because if you see, in the case of 0, column is starting from 0. In the case of 2 also, in the case of minus 1 also. So we have to start a column from 0. So for int j equals to 0, j goes to l, and j plus plus, what do we have to do? So we have to also make a smaller matrix here. So name at vector or vector int s. I'm naming it as matrix mammity. Okay. What was I? No, mammity is already defined. So s mat. S for smaller, mat for matrix. Okay. And then here define the row vector int row. Then what do we have to do? Now for int j equals to 0, if j is not equals to that column, then row dot push back mat I j. After that, both the loops nested loop will end, and we will push the row into smat dot push back row and end the loop. Now we have got a smaller matrix. Like for one, let me rub and make it easy to understand. In this, after the nested loop statement, for this one, we would get this matrix as smat. Subsequently, for 0, we would get this row plus this row, these two rows as matrix. Okay, the trend will continue. After that, we have to just calculate our answers value. So int smaller determinant equals to, call that function again, which is defined above for calculating determinant, and now calculate the determinant of smat. So determinant of smat will be, the size will be n minus 1, because we have reduced one row and one column. The previous size was n, so 1 minus 1 will give us to n minus 1 star n minus 1. So function of n minus 1 comma send the smat matrix. Now answer will be increased by answer equals to answer plus element star func, and the loop, then return the answer. Of course, it was an easy problem, nothing to be worried about. Very easy if you have a little grasp on recursion. Let me code it down for you real fast. So we have to give the answer. What were the base cases? If n equals to 1, return matrix 0 0. Else if n equals to 2, return matrix 0 0 star matrix 0 1. Oh, sorry, 1 1. Diagonal was 1 1 now. Then matrix 0 1 star matrix 1 0. After that, now for the remaining cases, what we have to do? Declare a variable answer, calculate the final answer. Then what were we doing? Yeah, for int column equals to 0, column less than n, column plus plus. Also we were dealing with the sign here. Sign was 1 initially, column less than n, column plus plus, then and element equals to matrix of 0, column multiplied with sign becomes is negative. If it was 1, it is converted to minus 1. If it was minus 1, it is converted to plus 1. After that, construct the smaller matrix. Construct the smaller matrix. For that, vector of int smat. Now for int This will be R here. For int I equals to 1. We discussed starting the row from 1 and column from 0. I plus plus. Then vector of int row. Now for int j equals to 0. For int j equals to 0. J will go up till n. J plus plus. Row dot push back. Oh, if condition also. If j is not equals to column row dot push back matrix of I j. After the conversion, after that, push the row into the smat dot push back row. After that, calculate the determinant of the smaller matrix. Int data equals to determinant. If you can see, it is determinant of matrix. So let me copy this. Determinant of matrix. It would be now n minus 1 is the size and s mat is the new matrix. After that, answer plus equals to data star element and then return the answer. Hope it works. Let me try to compile and run it. Hope I have not committed any mistake in typing. No, there has been a mistake. It says n data equals to 0 minus. Oh, it would be n minus 1. I have written mistakenly in front of smat. It would be smat n minus 1. The order has changed only. Because of the zoom I was not able to view. Yeah, compile run is correct. So let me see the submit button also. And as you can see that this is a correct submission. Thank you for watching the video. Please don't forget to like and subscribe. Your subscription and your support means a lot to me. Keep watching, keep struggling, keep hustling. Thank you.